Once again, I cannot help but wonder how, when the answer is supposed to be something like the number 7 and you get 2,732,000, that at some point you're not even getting close to the answer. Logically the answer, something like the answer. Are we ready? Buckle up, it's going to be a 4-ticket ride today.
Just do all the problems.
I'd like to go with the ones that are difficult first. Connor Morgan. Ladies and gentlemen, we have a 16 on the table. I really should have you field this question, children. Somebody want to shoot at me what I'm going to do here? There actually are a couple different ways to do this, but you would not get it that way, so let's just say, anybody. If I ask you how to do this problem, you tell me to do what, Chase?
Multiply 5.6 times 4.
Yeah, what do we call that in the mathematical world? Cross products. The first thing you should try to do is say, well, how do I go from 2.8 to 4? And you really can't, but you can really. It's actually what?
Point something.
Yeah. Okay, so we'll just go with this. Ready? So Chase says you do this. You have to multiply the diagonals. I always try to do the x first. 2.8 times x has to equal whatever this times this is. 4 times 5.6. And I'll try to do this math relatively quickly, so this should not be the part that gets you. You should, if you get this far, you should get the right answer. 4 times 5.6 is what? 22.4. Then you divide by 2.8, as we always do with equations. Divide by 2.8, and if you take 2.8 into 2.4, move the decimal one place, here goes in your answer. Oh, 28 goes into 224, what?
8 times.
Ooh, exactly?
Yep.
Yeah,
Yes.
64, 6, 16, 22. So the letter X. If you have a question that's relatively close to this, so I don't have to keep flip-flopping, that would be a good one. Sittler?
17.
Yeah, I don't. 17 is one of those where I don't understand why it is so much of a trouble for people.
Well, I forgot the steps.
Well, there's not much of the way steps. They're pretty simple. This, by the way, is a division problem. Step number 1 is you divide the left side. So I'm going to divide this, which is pretty simple. 1.2, bottom into top, gives me 0.6, which should cause you to shudder, because you know that that won't be scientific notation. Is it something to look forward to?
Oh, yeah.
Oh, is it? Oh, I know it is. And then, write down your times 10. How do I get the exponent of 10, children? This is where you have to be careful. If I was writing notes to myself, this is what I would highlight and star. With multiplication, you add exponents together, but this is division, so you subtract. And that's where you got to be careful, because you subtract the bottom from the top. The actual problem would look like this. I am taking a -2 away from a +5. And when you subtract a -2, that actually is
Addition.
adding, because two negatives next to each other make it plus. So you end up with times 10 to the 7th. To which you're going to say, well, that wasn't the answer.
That wasn't the answer.
Why is that not the answer? Because this is not in scientific notation because of our gasp before. This needs to be between 1 and 10, so you have to move the decimal here. So it becomes between 1 and 10, and then this is where the second place where the wheels fall off. How do I know what to do with my exponent here, Chase?
If you make the decimal big, the decimal big, you make the exponent.
Yeah, it balances out. I made this bigger by 1 place, so I have to actually make that smaller by 1 place. 6 times 10 to the 6. All of these notes will help you tomorrow when you take this book of the test, which is autumn.
Number 18.
Look at, we are making our way in the world today. Takes everything we got. I'm going to start off with the numbers first, and then we'll talk about the letters. If you're reducing 24 over 16, what number goes into that, Bri? What number can you reduce those by? The numbers? Higher? You could cut them in half, but let's go right for the jugular. What's the biggest number goes into those? 8. You could do 2 and you could do 4, but you're going to have to keep doing that. So I'm going to divide both of these by 8. That makes this A3 and this A2. Now we don't deal with negative exponents, so I have to do something with this y to the negative 1. What should I do to the y to the negative 1? Zachary?
Move it to the bottom.
Yeah, move it to the bottom. So when I put a y to the second with a y to the 1 on the bottom, I end up with a y to the 3. No other y's left on top. On the bottom, now these are all positive, so I can deal with them. I have x times x on the bottom, that's x squared. And then I have x times x times x, that's x cubed on the top. Crossing them out 1 for 1. 1x with 1x, a second x with a second x. Left with 1x on top. So what do I have left on top? The 3 and the x. What do I have left on the bottom? The 2 and the y cubed. I always like it when I hear people go, oh, that makes sense. However, sometimes I wonder if it's or memorize. Emma Miller.
I don't understand number 11.
Is that on this page or the other? How about this? Here's a question for y'all. Why does the problem say to use 2 unit multipliers?
Because you only use 2 multipliers. Said you only need 2.
But I can change feet into yards. If there's just 3 feet in a yard, why do I need 2 of them? So?
Because it's feet squared and yard squared.
Exactly. Because it's the label. It is square feet. It's not 54 squared, it's 54 square feet. It is 54 feet times feet. It is square feet. And I need 2 unit multipliers because 1 unit multiplier only cancels off 1 label, and the second unit multiplier cancels the other label. And I'm changing it into yards, so it goes yards up top. And then you have to have a little knowledge how many feet are actually in a yard.
3.
3 feet in 1 yard. By the way, your unit multipliers will be always identical. And then doing the math, feet cross off, 2 feet to 2 feet. We're left with 54 on top, 3 times 3 on the bottom, which happens to be 9. And 54 over 9 ends up being 6. And what label is left?
6 yards cubed.
By the way, if I were you, children, if I were you, on tomorrow's test, I'd guess 6, because that seems to be the answer for everything. On the pretest. Wasn't it? Did we do 6? Wasn't 6 the answer for... How many answers of 6 did we have? Okay, 2. But at least if we get 2 answers right. Chase!
How would you do it?
Who?
17?
That's not it. 19. 9. Oh, children. Oh, which, by the way, this is a good time for me to throw this at you. Yesterday on the test, or on the quiz, I said, prime factorize that. This doesn't have any squares in it, so your answer shouldn't have had any squares. This has nothing to do with square roots or anything. You should have just prime factorized it. Like 8 of you did. Got me an answer that was like 2 times the square root of something. There's no square there. This one, in fact, does have squares. So, Chase, what do I have to do? How about this? Prime factorize this. If you don't know, do the tree thing. Maybe some of you will catch this. What times what gives me 3,600? The square root of 36 times the square root of 100. Now, if you think about this mathematically, children, look at both of these. These are both perfect squares. You could really stop right there. The square root of 36 is
6.
And the square root of 100 is,
10.
so these would both drop out and give you a 6 times a 10, which your answer is 60. If that doesn't make no sense to you, then you just keep right on breaking these down. Square root of 6 times the square root of 6. Square root of 10 times the square root of 10. Square root of 6 is the square root of 2 times the square root of 3. Square root of 2 times the square root of 3. 10 is the square root of 2 times the square root of 5. 10 is the square root of 2 times the square root of 5. If I line those all up in order, I have 1, 2, 3, 4 square roots of 2. Real quick. Square root of 2, square root of 2, square root of 2, square root of 2. I have 1, 2 square roots of 3. And I have 2 square roots of 5. And when you get to this point, remember you're looking for mates. Hey matey, gives you a normal 2, gives you a normal 2, gives you a normal 3, gives you a normal 5. All the square root stuff crosses off. And lo and behold, what is 15 times 4? All right, nobody knows. 2 times 2 is 4, times 3 is 12, times 5 is 60. Which is what we would have got if you had said, well, the square root of 36 is 6, and the square root of 100 is 10. 6 times 10 is 60. All about what you want to do. Might as well do 20 while I'm sitting there. Square root of 18 breaks down into the square root of 9 times the square root of 2, and the square root of 9 is 3, so you can stop there and get 3 times the square root of 2. But if you have to break this down into the square root of 3 times the square root of 3, prime factorize this gives you the square root of 2 times the square root of 3 times the square root of 3. 2 identical square roots of 3 give you a normal square root of 3. And you have that. 3 times square root of 2. We are on the race now. Told you it was going to be fast and furious. Autumn. Number 10. Is that the next page here? Look at that. Nice. The sides of a square increase by a scale factor of 2. The area of the larger square is what percent of the area of the smaller square? Oh, that is I will say this is probably a tough one. Did you draw a square, Autumn? Yeah. How big did you make Mr. Square? Did you write dimensions for the square? Because you have to. I'm not sure how you can do as well. What dimensions am I going to use? Caleb Fisher, what would I use for my square? Did you not draw a square?
I did too.
Huh?
5.
Alright, I'm skipping that. I'm not going to do 5. Well, wait.
7.
I can do it. Let's do 5. I'll do 5.
Not 7 trees.
It's a square. So if it's a scale factor of 2, the new square is going to be 10 times 10, right? And we are talking about their areas. So what is the area of the small square? 25. 5 times 5 is 25. Area of the big square is 100. Here, ladies and gentlemen, is where I'd stop and draw myself a little percent box. Alright. This is the actual area. I'm going to write that down first. Okay. We are increasing, right, by a scale factor of 2, we're increasing, so you've got your original plus the increase equals final. What was my original? What, 25? Ended up being 100, right, which is an increase of 75. My original percent always starts out being 100%. Wait, no, that's not what this is asking. Wait, does it say how much increased it is? No, it's what percent of the smaller square. It doesn't say what increase it is. So this plus this would give me 100. Was the answer what percent of the area?
The answer was supposed to be 0.
Oh, maybe it is. This was 100. Sorry. This was 100 plus what 2 numbers give you this? So 25 times what is 100? 75 times that. I'm looking for the final one, so 100 times 4 is 400. It was an increase in percent. Increase in percent. Just know that tomorrow you will draw this same square. It will just be probably a scale factor of something else. Now, can I tell you, your life would have been easier, Caleb Fisher, or whoever's doing this. A recommendation I would have to you is start with the smaller square being 10, and then doing the bigger square, because then all of these numbers will match up to be exactly the same. You don't have to worry about multiplying or dividing any of this, because your original percent will start out being 100, and blah, 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 blah. Or whatever, this will start out being 100, I'm sorry, and then everything else will match up with that. I would asterisk that. Highlight it, boldface it. Joseph.
How are you doing number 3?
Number 3. Is that this page?
Yep. Straight up.
The first one? If anytime I'm asked something like this, because this can be kind of confusing, I would first answer the question, instead of percent, ask yourself what fraction it is. Instead of percent, and then change the fraction to a percent. 5 minutes is what fraction of an hour? So if you're making a fraction out of it, how many minutes are there in an hour, Joseph? 60. So there's my fraction. I just want to make that into a percent, which means I want to make the bottom 100. 5 times what number equals that? And it's not going to be pretty, by the way, because it doesn't work out evenly. I could reduce this to what? Do we know what 5/60 is? But let's not. Let's just do it the way it is, because let's just do multiply, cross multiply. 60 times n equals, what's 5 times 100? 500. So divide 500 by 60, which we could do easier than that. But 60 doesn't go into 50, but it does go into 500 8 times, which is 480. What's left over? 20. Make that a fraction. 20 over 60 reduces to 8 1/3. If you put 0.33, I probably would have given it to you, but it did ask for a percent, so let's go with that. There probably are some other ways to do that. If you did it the other way and got a different answer, or the same answer, that is fine. Gianna.
What are you doing number 1?
Wait, we did number 1, didn't
No.
we? We didn't do number 1. Well, it's a ratio, so I would do a ratio box. What are we comparing? Doctors who recommended it compared to ones who did not recommend, and that would be the total number of doctors. What is my ratio and what's my actual numbers? 3 out of 4 doctors recommended the product. So where do those numbers go, Gianna? Where would the 3 and the 4 go, if 3 out of 4? What is 3? Is 3 how many recommended, how many didn't recommend it, or how many total doctors there were? I'm sorry, what? 3 recommended. Is 4 how many didn't recommend it, or how many doctors were surveyed? Doctors surveyed. So you know 1 doctor did not. Now what do we know? There were 60 doctors surveyed, did not recommend the product. Where does that go? The 60, how many recommended, how many did not recommend, or how many total doctors there were? So that goes here. And they want to know how many were surveyed, that's total. Which is pretty simple because how do you go from 1 to 60? Multiply by 60. 4 times 60? 240. How many people got that wrong? Really? Because you answered probably how many recommended it, or you answered something else.
Yeah.
Lauren, I need a confession. What did you do?
I put instead of the 3 on top and the 4 on the bottom, I was 3 recommended and 4 did not recommend it.
For a total of 7 doctors. Leighton Purdue.
Do you do number 2?
Did we do number 2?
No.
I swear we did some of these. Maybe that was last year. A used car salesperson purchased the car for $4,000 and sold it for 40% more. What was the selling price of the car? What type of problem is this? Zachary?
Is that increase?
It's an increase in percent. He sold it for 40% more, which could have been said a 40% increase. So once again, it kind of becomes old hat. We've got our original percent plus our increase in percent is our final number. Here's our percent, here's the dollars. Original percent, always 100. Percent increase, 40. Final price, those two added together. What is $4,000? Is it how much originally he bought the for, how much he increased the price, or how much the car costed in the end?
Original.
What's that?
Original.
Original. That's how much he bought the car for before he marked it up. So 4,000 goes here, which again should make you happy because how do I go from 100 to 4,000?
Multiply by 40.
Yeah, multiply. If you multiply by 4, it'd only be 400, so you have to add a 0 for it to 40. Multiply this by 40. 40 times 40 is 1,600. Multiply this by 40, 5,600. I'm not going to do that, man, because you can do it. Now, what did they ask you? Selling price, which is the final price. 5,600 shimoles. How many of you got that one wrong?
Raise your eyes. Don't be ashamed.
Wow, Zach, what up with that? More questions. More, Autumn.
How do you do
Number 4. Remember this, if they tell you to do this, by the way, do you see any equal signs? No. The only thing you can do to this is maybe factor it. And factored is reverse distributive property. When it's reverse distributive property, you look at both terms, there's 2 terms there, and you ask yourself, what can I remove from those terms? What do they have in common that I can take out of them? Well, you look at the number 2 and 3. What number can you take out of 2 and 3? Divide them by 1. But 1s don't do you any good, because if you take a 1 out, you just get the same thing. What do they have? They both have some x's. And what do they have in common? Just one x. I can't take 2 x's out of that because there's only 1 there. So that's my common factor right here. This is what they have in common. And now I have to reverse distributive property that out. If I take one of the x's away from the x squared, I'm left with still the other x. Keep this same sign. If I take the x out of the 3x, I'm still left with a 3. No more, no mas, no mes mas, no mas mas, the madre would say. It's like blurry.
do you do number 7?
Or do I do it?
Yeah.
Alright. Oh, find the area of a trapezoid. Well, that would mean I'd write down the area, Emma, of a trapezoid, which is?
Area equals half is 8 1 times plus 8 2.
We have that written down?
Yeah.
And then before I even look at that, what are the bases, what are the heights? What are the bases, Sarah, Grace, what is the bases of a trapezoid?
12 inches.
Well, what are they? If I did, I'm not looking at it, how do I know what the bases are? You're probably right, but I just want to know what do you know? How do you know what the bases are and how do you know what the height is? The bases are the two parallel lines, and the height is that right angle one that goes to those parallel lines. So if I go up here and look at my trapezoid, the two parallel lines are here and here. That's what you said, right? 12 and 22, because you have to put those together. Yep. Am I on the right page here? 1/2 of 12 plus 22. And then the height is whatever forms the right angle. Oh, there it is. What line is that forms the right angle? 12. You get that right. Now it's all over but the math. Remember, you can't take half of just this 12, because this is in parentheses. You need to actually do that first. Parentheses get done before multiplication. 12 and 22 is 34. Now you can take half of whatever you like, or multiply 34 times 12. Do it however order you want. I would take half of 12 and get 6, and then take 34 times 6. 204, whatever that was. Inches squared, cubic squared, inches, feet squared, whatever, etc. Same thing, area of a triangle. Let's just do that real fast. Triangle is 1/2 base times height. This is only one base. That's the bottom that forms the right angle. Right here is your triangle. Base has to be this, and it has the same height of 12.
So 60.
What's that?
Just 60.
12 times 10? Is that what it was? Is that what Zach was saying? I can't hear. Half of 12 is 6. 6 times 10 is 60, whatever it was. Was it inches? I should probably look. I'm out of breath. Madison Sittler?
Number 6.
No, not number 6. Didn't I do number 6 already? Oh. And again, writing down the formula for the area of a parallelogram. Area of a parallelogram is just base times height. You have to understand what the parallelogram is here. Parallelogram is just this piece right here. And the base and the height, uh-oh. And the base and the height, uh-oh. And the base and the height, well, here's the base, which is 12. And it don't matter, even if this thing is out here, it would be the same thing as if it was drawn right here. This little thing with the square corner, that 12 is still the height of that shape. So area equals 144.
You said it? Oh, wait, yeah. Never mind.
I'm sorry, would you say that again?
Sorry.
Yeah, repeat that last word again.
Sorry.
That's so refreshing. Wait, did I say it right? I did say it right, didn't
Yes.
I? Did you hear it wrong?
No.
Autumn?
I didn't have a 5.
Wait, I did 5, didn't I?
No.
How can that be? Must be getting close, are we? My voice is getting sore. Number 5 is what we like to call theoretical or experimental probability. Anybody? Huh? Experimental. That's why you can't have theoretical probability of somebody making a free throw, because there's no mathematical formula that tells me how many free throws Caleb is possible of making. So it has to be an experiment. What did the experiment say? He made 24 out of 40. That is your probability. You just need to reduce the fraction. What number goes into those? Well, let's try dividing them by 4. Oh, look, we get what? 6 over 10. Cut them both in half again. You get 3/5 is your probability. Should be making 3 out of 5 read those. Number 5, I would just say make a fraction and reduce. Make a fraction and reduce. Gotta be getting somewhat close, huh? Whose turn is it? Emma!
How do you do number 9?
We did number 9, didn't we?
No.
Graph 1/2 x plus 1. Does the graph indicate direct variation? First of all, how do I graph that, Em?
You go up the 1 and you go up over 2.
Where's my starting point on my graph? 1 on the y-axis, because this is my y-intercept, so I put my little point there. This is my slope, which is what you said, up 1 over 2, or down 1 over 2, either way. Here's your line. How do I know if I have direct variation? Anybody? Direct variation is really the same thing as proportional. Two things have to be true for something to be proportional or be direct variation. The first thing, ladies and gentlemen, is it has to be a straight line. Do I have a straight line? In fact, I do. But point number 2 is not met because point number 2 is, Chase?
Has to go through the origin.
It does. It has to go through origin. When x is 0, y has to be 0 for something to be direct variation. For it to be proportional, because you can't. There's no constant factor. It's not. You could make a table and try to figure that out. Most of you aren't carpenters, so that don't have to work. Siddler?
Number 14.
I know I've done that one.
No.
Is it over here? Is it that one?
It's on the back.
Am I on the wrong page?
No.
Oh. Wait, is there a, well, I would probably actually tell you to ignore that one because we haven't talked about it. This actually, it actually shows you it's actually the Pythagorean Theorem, isn't it? Is that what the answer was?
Yeah.
Tell you what, you'll skip that problem because we haven't already done that as a thing. If that one comes up tomorrow, it's probably also going to be Pythagorean Theorem, but I won't count it.
Close, tight, skip, 14.
You write whatever you want on it. Thank you. Have a happy day. I love math. Math is better than any other subject here. No, Chase. Don't, Chase. Don't belittle yourself. Autumn.
How do you do number 13?
I know we did that one. The formula for the following sequence is A sub n equals 2n minus 1. Ladies and gentlemen, what do you need to know about this? The letter n is what? The letter n is the number of the term. In which case, they're asking you for what numbered term? This one. This is the letter n. You just put that in for the letter n and everybody's happy. A to the 50th, which just means that's a label, it's not a number. 2 times 50 minus 1. What is 2 times 50? 100. And 100 minus 1 is 99. Now you could, if that really bothered you, feel free to continue the sequence and count the terms until you get to the 50th term. That would always work. It's kind of the hard way, but hey, if that's something that floats your proverbial boat, then by golly, set it out to sea. Yurt.
How do I do number 15?
I know we've done that one. Somebody? No. Is it this one? Is it this one? Wait, was that the one I said don't do? Oh, that's a good one to do. How come nobody's asked on that one? First thing you should do on any equation, somebody? Madison?
You get rid of the extra numbers.
Nah, no. You look at each side and see if you can combine something and simplify it. Is there something I can do on this side? I can put those two x terms together. If I have 4x, subtract an x from that, I have 3 x's. The minus 5 sticks around because I can't do anything with that. Now I've simplified everything I can now by adding and subtracting. I move things. What do I have to move? I can get rid of the 5 by doing what?
Subtracting 5.
Nope.
Or adding 5.
Add. You always do the opposite. It's minus, so I add. I end up with a nothing here. 3x equals 12. And then generally you'll find a pattern here. The last thing you're going to do is divide. How do I get 3 times x? I divide by 3. Divide by 3. So x is going to equal 4. Wait, do you only have one left?
That would be number 12.
Wait, it was 12 one that we already did?
It was the net one.
Oh no. I am not going to do that again.
I don't know.
No, it's punny. Yes, it is. What we could do is let's watch. Where's my pen?
What are you looking for?
I'm looking for the other group. But it is there. And then the delete button. Is there a delete? Cut?